Okay, so in this video, I'm going to be going over and explaining some of the solutions for the first written exam. I graded questions 1 and 2, so I'll be going over those in this video. Guna and Greg graded the rest, so they will also be posting videos of what they saw when they graded, but this video is going to cover 1 and 2. Okay, so starting with 1A, this was the fill in the blanks portion of the test. Basically, you had a bunch of options, and then you had to fill in the blank according to what the sentence said that made the most sense. Okay, so the first one is the main unit of a computer that processes instructions is called the CPU. CPU stands for Central Processing Unit, so if you just remember that acronym, that should be pretty self-explanatory. And the instructions are delivered to this unit from the RAM one by one. RAM stands for Random Access Memory, and this basically is the part of your hardware that runs all of the applications that are currently open, and it kind of organizes it and then sends it to the CPU to be processed. Alright, so my version of the test is actually different from yours because Guna changed it before he printed it. And so this should include a 6 option that's bit right here. Most people got this wrong. I think I saw 1 or 2 people that got this right. A byte is the smallest addressable unit in a machine. And basically the explanation for this is that a byte is made out of 8 bits, and what a bit essentially is, it's a gate that's either open or closed, something that's either on or off in the very, very, very bottom level of your computer. So you cannot actually, from the top level of your computer, go down and tell one single bit to either turn on or off, but you can tell one byte to change. So a byte is the smallest unit that can actually be changed by the user. So that's important. Alright, so, and last, Ruby is an interpreted language. Again, I have a different copy of the test than you do. This was replaced by scripted on your exam. That is incorrect. So basically how I handled this was that if you put either compiled or interpreted, I gave you the point, but just know that Ruby is not a compiled language, it's an interpreted language. So it goes down and reads each line and interprets it one by one. And however, if you did put something like RAM, CPU, byte, or bit for this blank, that's completely incorrect, so that's no points. Alright, so 1B, once digital data about you is stored by a third party, can you be sure that it can be completely expunged upon your request? Why or why not? This was from Blown to Bits, it was in your homework, so it should be pretty self-explanatory. No, because third parties regularly back up their databases for security reasons, so basically when your copy is out there, you don't know if a backup of that containing your information has actually been deleted or not. Alright, so 1C. A megabyte is 2 to the 20 bytes, and a kilobyte is 2 to the 10 bytes. So if you have a storage device with a capacity of 1 megabyte, how many files can you fit in that device, assuming that each file is 2 kilobytes? So express the result as a power of 2. Basically, how we should have approached this problem is that we know our storage device is 2 to the 20 bytes, so we need to figure out how much is left after we have 2 kilobytes of stuff already stored there. So we can think of a kilobyte as 2 to the 10 bytes, and if we have 2 of those, we have 2 times 10 to the 2 bytes. So that also, in other words, is 2 to the 11th power. So if we were to subtract 2 to the 11th from 2 to the 20, which is the total amount of storage that we have here, we get 2 to the 9th. Alright, so 1D. Moore's law says that the number of integrated circuit chips doubles every 18 months, which implies that computers become twice as powerful every 18 months. So according to Moore's law, how many months does it take for a computer to become 16 times as powerful? Okay, so the way to think of this is to think that every 18 months, the power of a computer doubles. So we are asking how many months it takes for a computer to become 16 times as powerful. So we know, if we were to think of this in terms of base 2, we know that 16 is 2 raised to the 4th power, which means that this has doubled 4 times. So now that we know that it doubles every 18 months, we can multiply 4 by 18. That becomes 72. So that's 72 months or 6 years. Either answer is acceptable. Okay, so 1E. In your own words, describe briefly what distinguishes a digital footprint from a digital fingerprint. Another homework question, basically what I was looking for is that a digital fingerprint, or a digital footprint, excuse me, is something you consciously leave behind. So if you're signed in somewhere and you have your username and password, you obviously probably know that you're traceable. A digital fingerprint is something that you don't consciously leave behind. So we talked about like laser printers and the encryption that they leave with the serial number, time and date, stuff like that. Most people didn't have a problem with that. So Okay, so number two. 2a, this is basically a bunch of Ruby expressions, Ruby operations that you were asked to do and come out with some number. Pretty simple, so I'll briefly explain each one. This is integer division. So 9 goes into 64, a total of 7 whole times. And so this is exponentiation and then multiplication. So 3 squared is 9 times 2, 18. Over here we have 4 times 2, which is 8, plus 6, 14, minus 1, 13. Okay, so this is not integer division, it's floating point. So we get 6.5 as the answer. This was a little bit more tricky that half of the people might have got wrong. So if we go here, we start with the left. 34 divided by 10, and this is integer division. So 10 goes into 35 a total of 3 times, like 3 whole times. So we end up with 3 mod 10, and then the remainder of that would be 3. Okay, so if you type in 2 does not equal 3 into Ruby, that is true, so it will return true. Alright, so 2b, suppose that we type the following assignments into IRB in the given order. So here we have 5 assigned to x, 10 assigned to y. Okay, and then if we use these assignments, we get 15 plus 10, which then gets stored to the variable x, which means that x has been overridden and now 15 is stored into x. So if we were to take x again and use it in this next assignment, we get 10 plus 15, 10 being the the value assigned to y, 15 being the value just assigned to x, and then we would get y as 25 because the previous value was overwritten. So over here we have those values, and also if we were to mod 25 by 15 over here, we get 10. 10 divided by x, which is 15 right here. Integer division, 15 goes into 10 0 times, so the answer is 0. Okay, so this function right here, write a Ruby function is even num. That returns true if the number is even and returns false otherwise. Pretty simple. You all should have gotten this right. Some people did not put an end statement here, so the point of written exams is that if we type in everything that you wrote down on paper into IRB, it should output exactly what we want it to. End statements are important, treated exactly like a lab exam. So if you did forget to put an end statement here, I took off 1 point out of 4. It's not going to kill you, but just make sure you are doing that on lab exams or on written exams. All right, so that is wrong because I need an extra 0 here. But okay, so write a Ruby function place 10 num that returns a digit of the place 10 for a given number. So for example, place 10 34 will return 3 right here. Place 10 7 will return 0 because there is no 10. And then place 10, this number here returns 6, so that's right there. So hint, the operators mod and integer division will become handy when solving this problem. Okay, so what you essentially had to do here was take num, and then you would mod it by 100, which gets rid of everything over here and only leaves these last 2 digits. Okay, and then you would take what you just got, divide it by 10, which ensures that you do integer division, and you get this number right here. And then you return it, and you're pretty much done. Alright, so 2e. Use the idea of the previous problem, now write a function in any place that will extract the digit on any place given to the function. So you got a bunch of inputs and outputs here, and you were looking for something like if we gave you 4, the ones place counts as 0, so anything past that is numbered accordingly. So the idea of this was that if you were to get a number in a place, you would divide that number by 10 raised to the whatever place was. So for example, if we were to take this example here, if we raised 10 to the 4, that would be 1000, and if we were to mod this number, or sorry, divide that number by 1000, this number would go into, or 1000 would go into this number a total of 4 whole times. We replace num with that, and then we take what we just got, mod it by 10, and then what would happen would be that we would get the rightmost number after we've gotten rid of all of this. So it would work if we replace this, for example, if this number here were 3, it would get rid of everything to the left. So we would only keep the rightmost value after we had gotten rid of everything on the left as well. Okay, so that's pretty much it for that function. Okay, so the last one, 2f. So this is basically a mystery function that you need to trace and then decide what it does here. So if we were to go ahead and trace this right now, I equals to 1, okay, so something initialized at 1. R equals to 0, we have no idea what it is now, but it is starting at 0. We implement a while loop here in which I is less than or equal to n. We're going to continue doing this. Okay, so if you look here, r equals to r plus I, and I is the incrementer, so it's going to go from 1 to 2 to 3, all the way to n, whatever that is, and we know that because it keeps getting incremented by 1. So if we were to look here, r starts with 0, that's our first hint, and then we increment all the way up to n, and then keep adding that. So it looks a lot like we're adding all the numbers between 1 to some number n, and so that would essentially be what this operation here is here. We talked about that in class. So if we had like 100, if we were to place that by that, it'd be 50-50 because 100 divided by 2 and then plus n plus 1, or times n plus 1. So this is the expression for the sum of all the numbers between 1 and n. Alright, so that's pretty much it for this part. Hope you're happy with your exam scores. If you're not, come talk to us if there's something that you're confused about, but hope you have a great rest of the weekend, and I will see you in class tomorrow. Okay, bye.